Hey everyone, and welcome. I'm so excited to guide you through today's topic. If you've been working with Spring for a while, you definitely know the drill when it comes to making HTTP calls. We've all been there, relying on the trusty old ways to get our synchronous tasks done, right? But today, as a senior engineer who has wrestled with plenty of boilerplate, I want to show you a much better path. We're going to be upgrading your toolkit to the modern Spring REST client.
Okay, let's dive into this. Here is our architectural blueprint for today's explainer. First, we'll cover the modern Spring REST client. Second, our goals and prerequisites. Third, Step 1, project setup. Fourth, the application directory structure. And finally, we'll wrap up with a summary and our next steps.
Section 1. The modern Spring REST client.
So, if you've written HTTP calls in Spring before, you've almost certainly relied on the trusty, and let's be honest, maybe slightly rusty, RestTemplate. It has literally been the industry standard for a long time. But technology evolves, right? RestClient is its highly recommended modern successor, introduced in Spring Framework 6.1 and Spring Boot 3.2 onwards. Basically, if your HTTP calls are synchronous, meaning you make a request, you block, and you wait for the response, this fresh client is exactly what you want. It brings a much-needed structural facelift to how we write these calls.
And here is the absolute most important takeaway. I love this punchy tagline. REST Client gives you a clean, fluent, builder-style API without dragging in the whole reactive stack. You get that wonderful modern web client feel, with those chained methods that are incredibly easy to read, but completely without the heavy reactive overhead that you just don't need for straightforward synchronous apps. It's a real game changer.
Moving right along to Section 2, Goals and Prerequisites.
Let's move to and see how this builds. Before we write our code, here is exactly what we are going to build today. We'll set up a Spring Boot project from scratch, configure a REST client bean with our specific timeouts, attach default headers that just seamlessly ride along on every single call, and finally, we'll send per request headers, query parameters, and path variables.
To follow along seamlessly with me, you'll want JDK 17 or higher and Maven installed. We're utilizing a very modern stack here, Spring Boot 4.06 and Spring Framework 7. And to make this incredibly practical, we're going to point everything at a public demo API, specifically jsonplaceholder.typeofcode.com, so you can run every single piece of this yourself as we go. And honestly, best of all, no prior REST client or REST template experience is needed.
All right, Section 3, Step 1, Project Setup.
So REST Client actually lives inside the Spring Web module. The good news is you don't have to go hunting for that specific package yourself. And this brilliantly illustrates exactly what we need. Inside your pom.xml dependency tags, you just need the group ID org.springframework.boot and the artifact ID Spring Boot Starter Web. That's it, just those few lines of code. But listen, there's one crucial trap to avoid here. If you bootstrapped your project using the plain Spring Boot Starter without that -web suffix, REST Client won't be on your class path at all, and you'll get a very frustrating cannot resolve error. So always reach for Spring Boot Starter Web.
Section 4. Application Directory Structure. Let's get organized.
Now, what's really interesting about this slide is how we cleanly break down every single directory so you always know exactly where each piece lands. Starting from our root package, we have our main REST client application.java file housing our Spring Boot application and configuration property scan annotations. Then, notice our beautifully separated packages, a config package for our properties record and our REST client config bean. We have a controller package for our post controller to expose our API endpoints, a model package holding post.java, which is our response pojo constructed as a sleek Java record, and a service package containing post service, which actually executes the REST client calls. Finally, down in your resources folder, you'll find your application.properties for externalizing URLs and timeouts. It's a perfect, clean architecture.
And that brings us to Section 5, Summary and Next Steps. Okay, let's review what we've accomplished. First, we identified REST Client as the definitive modern choice for synchronous HTTP calls in Spring Boot. Remember our core tagline. It gives you a clean, fluent, builder-style API without the reactive overhead. Absolutely crucial. Second, we successfully configured our pom.xml with the Spring Boot Starter Web dependency to avoid any of those annoying class path resolution errors. And lastly, we mapped out a really robust production-ready application directory structure, cleanly separating our configs, controllers, models, and services.
So the crucial point is that what we built today is just the scaffolding for something much more powerful. I highly encourage you to check the description for the detailed article link. It contains the full implementation details so you can see all the code up close and copy it into your IDE. Practice this setup because we are definitely going to build on it. In the next part, externalizing config with @configuration properties will dive right into handling base URLs and timeout syntax. Until then, I want you to ask yourself, how much legacy boilerplate is still hiding in your microservices just waiting to be modernized? Thanks so much for learning with me today, and I'll see you in the next explainer.